Most beginners to C++ assume static fields are handled inside the constructor, but that's a trap. This misunderstanding can lead to unexpected reinitialization, hard to find bugs, and even thread safety issues. Today I'll show you exactly how static fields work and how to avoid some sneaky pitfalls that could be hiding in your code. When are static fields initialized? This question might seem simple on the surface, but the answer has real consequences, especially for memory usage, program design, and even multi-threading safety. Let's break this down step by step. So what is a static field? In C++, when we say a static field, we mean a static data member of a class. Unlike regular members, a static field is shared across all instances of the class. Here is what that looks like. This counter belongs to the class itself, not to any specific object. But here is a question. When and where is this field initialized? This is the heart of today's topic. Static fields are not initialized in the class constructor. Why? Because constructors run every time you create an object, but a static field is shared among all objects. It only needs to be initialized once, regardless of how many objects you create. Let me show you an example. Here the static field counter is initialized outside the class definition. That's important. Inside the constructor we increment it. But again, the initialization, the part where we assign it to 0, does not happen inside the constructor. This brings us to why it matters. Imagine this scenario. What's wrong here? If we do this, then the constructor runs twice, so the value is reset to 42 twice. That might not break anything in this specific case, but it's dangerous. It means every time you create an object, you're blindly resetting the static field. That's almost never what you want. Static fields should be set once, usually at the start of the program, or in very controlled conditions. C++ doesn't define the order in which static variables across different translation units are initialized. This is called the static initialization order fiasco. If you rely on static fields being initialized inside a constructor, you're essentially giving up control over when and how that happens. By initializing it outside the class like this, you make sure the compiler knows this field exists. Set it up before any object uses it. Static fields and constructors can be a dangerous combination in multi-threaded programs. Let's say multiple threads create instances of a class at the same time, and the constructor modifies a static field. Without synchronization, this leads to race conditions. Here is a hypothetical issue. If two threads construct shared objects at the same time, the total variable could be updated inconsistently. In contrast, if you initialize a static field once and use atomic types or proper locking afterwards, you avoid this. There is a valid case when you want to initialize a static field once, but only when needed. In that case, you should not use a constructor, but rather a static function. This leverages the local static variable idiom. Since C++11, local statics like this are guaranteed to be initialized only once, even in multi-threaded contexts. This is safe, and it avoids the pitfalls of doing this in constructors. Let's clear up a couple of misconceptions. Misconception 1. Static fields are automatically set in the constructor. This is false. Constructors are for object instances. Static fields live independently from instances. Misconception number 2. If I don't assign a static field explicitly, it's uninitialized. Not quite. If it's a built-in type and you don't initialize it, then yes, it's uninitialized and dangerous. But if it's an object type with a default constructor and you use the local static idiom inside the static method, it will be correctly initialized. Let's pause and summarize. Static fields belong to the class, not to objects. They are not initialized inside constructors. Initializing them in constructors causes repeated assignments, confusing behavior, and potential thread safety issues. You should initialize static fields outside the class for simple types, and by using static accessor functions for lazy or thread-safe initialization. Think of static fields like global settings for a program. Imagine you're writing a game engine. You might have a class like this. You don't want every object, like a player, enemy or tree, to reset the screen resolution when it's created. You want to set it once, maybe during engine startup, and then leave it alone. Let's talk a bit more technically. When you declare a static field in a class, the compiler expects to define it outside. Without this definition, the linker will throw an error. Usually something like undefined reference to field. So this code alone isn't enough. You must define it elsewhere. Only then does it get memory allocated and initialized. Are static fields initialized in the class constructor? No, and they shouldn't be. They live outside the object lifecycle. They need controlled, predictable initialization. Understanding this helps you write safer, faster, and more maintainable C++ code. So next time you write a class with a static member, ask yourself, where is it initialized? Is it safe to do it that way? And could multiple objects or threads cause issues? If you get that right, you'll avoid some very tricky bugs later on. Thanks for watching. If this helped clarify things for you, give the video a like, subscribe and check out the playlist on the screen. See you in the next one.